to be doing is we're going to be talking about the sum of the interior and exterior angles of all polygons. Okay, so we're going to talk about polygons in general today. Tomorrow we're going to start focusing on quadrilaterals. Okay, so first we're going to talk about the sum of all the interior angles. So we know about triangles. All right, we know that the sum of all the angles of the triangle is 180 degrees. And a lot of you remember or figured out that there's 360 in a quadrilateral, right? But what if I said there's 27 sides? You're like, I don't know, right? Okay, so there's actually a formula that we're going to discover to calculate that for us. All right, so we're going to go through and how to discover this formula. So I have this figure here. I have a pentagon, a hexagon, and a heptagon drawn out. But notice I've drawn in the diagonals from one vertex. Okay, so what did I divide all those shapes into? Triangles. Good. I've divided all those shapes into triangles. Now, notice this is 5 sides, right? This one was 6 sides, and this one was 7 sides. So how many triangles did I end up with in my pentagon? 3 triangles. How about in my hexagon? I have 1, 2, 3, 4 of them, right? I have 4 triangles. And then in my heptagon, 1, 2, 3, 4, 5, yeah. I have 5 triangles. Now think about the way that I drew all of those. We know that the sum of all the angles is 180 degrees, right? The way I drew all those diagonals in, I'm using up bits and pieces of each of the 5 angles, right? But they're all parts of those triangles. So what I'm saying is I don't have some pentagon. Oh, this is going to be a hexagon, sorry. I don't have some sort of hexagon with a triangle floating in the middle. All the vertices of all those triangles end up at a vertice of my pentagon, right? So if I have 5 sides, that created 3 triangles, and I can find the sum of all of those angles by taking 3 times 180, because there are 3 triangles there. Right? The vertices are in the vertices. The corners are in the corners together. Okay, if I have 6 sides, I can take my 4 triangles, and I can take 4 times 180 to find the sum of all the angles. If I have 7 sides, that gave me 5 triangles, so I can take 5 times 180. So I would try to come up with a formula that I can use. Let's say I have a 32-gon. So it has 32 sides. How many triangles is that going to have? 30. How did you figure that out? It's not a trick question. How do you know there's 30? It's always minus 2, right? It was always minus 2. 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. So the number of triangles is always 2 less than the number of sides. And then we multiplied every time we multiplied by 180 because it's the triangles, right? So our formula comes from taking 180 times n minus 2. N stands for the number of sides. Because you told me number of sides, subtract 2, would tell me the number of triangles. This is a formula you're going to want to know. I know this has come up on the ACT before, at least using the formula. Okay, so n minus 2, take that times 180. All right, so here's how this is useful for us. I could ask you a question like, find the sum of the angles of a nonagon. So how many sides does a nonagon have? 9, which means I need to take 180 times 9 minus 2. So I'm going to take 180 times 7. So what's 180 times 7? What do you think? 180 times 7? We want all of them together. 1,060. I'm sorry, I thought you just said 60.
No, I said 1260.
I'm so sorry. I thought you just said 60. Yes. I'm sorry. 1,260 degrees. So that means if I had any nonagon that I draw, if I were to measure and add up all of those angles, it would equal 1,260 degrees. Okay, does that make sense? All right, let's look at the second question here. It says find the measure of a single angle of a regular octagon. A single angle of a regular octagon. So keep in mind, a regular octagon means we have an octagon that has 8 congruent sides and 8 congruent angles, right? All these angles have to be exactly the same. That's what regular means. It's equilateral and equiangular. Right? Okay, so I can find the sum, but then I just have to divide it equally among the 8 angles. So let's first find the sum of all the angles. So the sum of my angles is going to be 8 minus 2, and then I have to multiply that by 180. So you should have 1,080 degrees as your sum. Okay, but then I have to divide the 1,080 degrees into the 8 different angles. You should have 135 degrees for one angle. So every one of these angles is 135. Make sense? Yeah. Okay, so here's the trick on these questions. You have to stop and read. Are they asking for one angle or are they asking for a sum? That's where people usually get themselves in trouble. Like they try to read the question too quickly, and then they don't really answer the question. Not that they don't know what you're doing, but they just didn't read the question carefully enough. Okay? All right. Next thing we're going to talk about are the sum of the exterior angles. Okay, so we were talking about an exterior angle. We were on remote, I remember, but we talked about extending a side of a triangle, and we said that this is called our exterior angle when we extend that side. And we said these two are called my remote angles. And the exterior was equal to the sum of the remotes. Right? Is that kind of ringing a bell? Okay, so an exterior angle is created when you extend a side. So I put a pentagon over here, and I extended the side of all 5 sides. Okay, I extended it. It looks like a starish type thing, right? So what I want to talk about, what we want to find, is the sum of all of these exterior angles added together. I want to find the sum of all those exterior angles together. So we're going to do that first just for our pentagon specifically. And then we're going to apply it to all polygons. So I want to know, first of all, what is the sum of the interior angles? So I want to know what's the sum of my interior angles. So that's what we just did. So take your n minus 2, multiply by 180. What do we get? 540? Good. So 540 degrees. If I add all 5 of those angles together, I get 540 degrees, right? Okay, we're just going to keep that in the back of our head for a minute. What do you notice about an interior angle and an exterior angle together? They make a line, right? They're linear pairs, so it's 180 degrees. Okay, so in this pentagon here, how many linear pairs do I have? 5, right? Because I have 5 vertices, 5 sides. So if I think about all my linear pairs, I have 5 times 180 degrees. But the problem is those linear pairs include all those interior angles. Now I just want to talk about my exterior angles. So I want to remove this part, this part, this part, this part, and this part. So those blue pieces there, what is that really? All those blue pieces together, my 540, right? Those are all my interior angles. So if I take all my linear pairs and get rid of the sum of my interior, I should be able to find the sum of my exterior. Does that make sense? If I eliminate the interior, I only have the exterior left. So if I take 5 times 180, I get 900 minus 540. Should have 360 degrees left. All right, so we're going to use this idea again, but we're going to talk about all polygons at once, not just a pentagon. Yes?
5 times 180 minus 3 times 180.
Yes, yes, but I'm trying to use that idea so we can build a formula. But yes, you're absolutely correct. That would work as well. Okay, so keeping in mind what we did here, we took all of my linear pairs in that figure and subtracted the sum of the interiors to get the sum of the exteriors. Okay, so we're going to do that together. We're going to do this for an n-gon. Okay, we've got an n-gon, meaning any number of sides. So if I say side, number of sides, we're going to put an n. Okay, so we're going to look at this from an n-gon standpoint. All right, so we took our linear pairs. If I have a 17 gon, how many linear pairs am I going to have? If I have 17 sides, how many linear pairs am I going to have? Yeah, the interior and exterior together. How many would I have? I would have 17. If I had 20 sides, how many linear pairs would I have? 20. If I had 30 sides, I would have 30 linear pairs, right? But we have n sides. So I'm going to have n linear pairs. So I'm going to have to take n times 180. That's all my linear pairs. Is that okay? Yeah. Okay, now, we took away the sum of our interiors. Well, lucky for us, we have a formula we figured out. Right? We took away, the formula we just did was 180 times n minus 2. Is that all right? That's a formula we just came up with. So let's clean this up algebraically. All right, so this would be 180n. I would need to distribute negative 180 to both of those. So I'd end up with negative 180n, and then I'd end up with a positive 360. Okay, so what's going to happen when I combine my like terms? It all cancels out, right? Well, all my variables cancel out. I'm left with just 360. So what this means for us is we don't even care how many sides there are. The sum of the exterior angles is always going to be 360. I could have a million sides, but some of the exterior is still going to be 360. Kind of cool, right? That's probably the easiest formula you've ever had to know. Yes? It's for any polygon, any convex polygon. So concave is a whole new beast. You don't even, if you have a concave polygon, you don't need to talk about the exterior. Okay, so this is all convex polygons. It doesn't matter if it's regular or not. That's cool. Yeah. All right. So let's use that idea. So the sum of all the exterior angles is always 360. Doesn't matter how many sides you have. All right, so let's answer a couple questions. Find the sum of the exterior angles of a hexagon. What's the sum of the exterior angles of a hexagon? 360, right? Okay, let's find the measure of one exterior angle of a regular octagon. So I just have to take my 360 divided by 8. What do we get? 45 degrees. Okay, so we just did this problem with the interior angle, right? We just did what's the measure of one single angle of the interior angle of a regular octagon. Okay, so we did this formula and then we divided by 8, right? To get 135. But faster. I mean, not a lot faster. I mean, it's not like we're doing like 20-step problems here, right? But a lot of times to think about the exterior angle, especially if you're talking about regular polygons, it's easier to think about the exterior than it is the interior. Because you're only taking 360 divided by the number of sides. If that's my exterior, keep in mind whatever that figure looks like, right? That means this is 45. My interior with the exterior is a linear pair. So then you can subtract and get 135. No, does anyone know what time this class is over? No idea. I don't know. I just work here. I don't know. Okay, so your homework tonight, I have it's posted in Google Classroom. Okay, it's a Google sheet, like it's a picture reveal. So if your answer is right, the picture will be revealed. Tomorrow, I have it posted already. There's a video to watch. The video is in Delta Math. Okay, it's in Delta Math. There's no math problems. You literally just have to watch the video. It's 9 minutes long. Okay, I made it today. It's only 9 minutes long. So make sure you watch that.